Good day, viewers. I welcome you to my class today on chi-square test for independence. I hope you are fine. I hope you have been watching my previous videos. The last video was on the test of hypotheses, and we looked at different types of hypotheses and were able to carry out a simple test. But today we shall be looking at chi-square test for independence. Once again, beloved, my name is Dr. Chris Isekaibe. I am a chief lecturer and a member of the academic board of one of the most prestigious polytechnics in Nigeria. I hold a doctorate degree in mathematics, a master's degree in mathematics, and a bachelor's degree in statistics. I've written quite a number of books, and I'm a member of the Nigerian Mathematical Society and also a member of the Nigerian Statistical Association. I have renowned publications at international and national level, and I've also attended conferences here in Nigeria and outside Nigeria. I work in Nigeria and I live in Nigeria. I would love to be your research consultant. I specialize in numerical analysis, data analysis and modeling, statistical analysis, and scientific computing. Here are my contacts. My phone number, you have to put the code, because if you are calling from outside Nigeria, you have to put this code +234. So it's +234 8033021903. This first one is WhatsApp number. The second one is not WhatsApp number, but you can call this one directly, +234 7066297535. Then of course you can reach me via my email address at chrisdavis2015@gmail.com. If peradventure you are an AI fan, you deal with artificial intelligence, why not? I can be part of your team of experts, team of mathematicians that will be developing advanced mathematical models and algorithms for artificial intelligence, or even advanced statistical algorithms for artificial intelligence and also machine learning. I'll be glad to be part of what you are doing, or you are a research firm in any part of the world, any English speaking firm. I would like to be part of what you are doing, and I will be looking forward to hearing from you. So permit me to claim this part of the board so that we can go into the business of the day. Today we are looking at chi-square test for independence. Chi-square test for independence. Now, beloved, when we talk about chi-square test, the chi-square test is a non-parametric test. It is a statistical test which is used to determine whether there is significant association between two categorical variables. It is used to determine whether there is an association between two categorical variables. Of course, it is a non-parametric test, and the data are nominal or ordinal data. So they are also qualitative data, and the data can also be called count data. Count data are data that can be counted. When we talk about categorical data, categorical data are data that are also qualitative. They are count data. You know, in one of our videos, I talked about parametric and non-parametric tests, and I talked much about quantitative and qualitative data. If you have a very good understanding of this, then you will know which kind of test suits or fits a particular set of data. Now, for the chi-square goodness of fit test or the chi-square test for independence, we normally use it to test categorical variables. The variables are two. So we test for significant association between two categorical variables. Now, when we talk about two categorical variables, it means that one variable will be on the row and another category of variable will be on the column. So if two variables are related, the probability that one variable having a certain value is dependent on the value of the other variable. So this test is used when we have counts of values for two nominal or categorical variables, and is considered a non-parametric test. So non-parametric tests are used to analyze qualitative data. Qualitative data are data that are categorized. For instance, male, female. When you talk about income earners, high income earners, low income earners, middle income earners, and the rest of them. So, and they are also count. Like for instance, you can only count the number of males. You cannot have 1.5 males. If you're talking about gender, for instance, you can talk about 1.5 gender, 2.5 gender. I say that they are count. You can count them in numbers and they are integers. For instance, you can either have 5 males, 3 females, 10 males, 5 females, and so on and so forth. So you can only count them. That's why they are called count data. They are data that can be counted. And again, qualitative data are different from quantitative data. Quantitative data are data that are measured in values, like for instance age, for instance weight. Somebody can be 35.3 kg or whatever the kg is. Height, somebody can be 1.6 centimeter and so on and so forth. So those ones are not counted, they are measured also in fractions. But qualitative data cannot be measured in fractions. They are count data. So the two variables we are talking about, one is given in the rows and the other one is given in the columns. Like for instance, I can give an example. You can have, they have cells. I can have cells like this, for instance, like this, and I have like this. You can call this, and so on and so forth. Okay, this one now you can call the values are called the observed frequencies. Then of course there is the expected frequency. You can call this one 011, 012, 013, 014, 021, 022, 023, 024, 031, 032, 033, 034, 041, 042, 043, 044. So these are cells. You can see it now. There will be a heading for the columns and there will also be a heading for the rows. So the variables are two categories. One variable will be on the column, the other one will be on the rows. And you can see these are cells. This one is the first frequency observed. O stands for observed frequency. Then as we progress, we'll see What we mean O means observed. This one is the first frequency in the first row and the first column. The frequency in the first row and the second column, frequency in the first row and the third column, frequency in the first row and the fourth column. This one is the frequency in the fourth row and the first column, frequency in the fourth row and the fourth column, and so on and so forth. So you have cells like this, and this leads us to what we call, these are called cross tabulation. So chi-square data are given in cross tabulation. So the chi-square test utilizes what we call the contingency table to analyze the data. So the chi-square test, this is the what it denotes. The full spelling is in chi-square, but this is the what it represents. This is chi-square test uses contingency table to analyze data, and the data accounts data that can be given in categories and so on. And so the essence of chi-square test is to study significant association or relationship between two categorical variables. We have to test whether the variables are independent or related. So the essence is to test whether the variables are independent or related. So it tests for association. So I will make use of this chi-square test for independence for non-parametric test. When the data are either gotten, remember we have 4 scales of measurement. We have the nominal scale, the ordinal scale, the interval scale, and the ratio scale. The nominal scale and the ordinal scale, data gotten using the nominal scale and ordinal scale are analyzed using the non-parametric test. And the chi-square test for independence is one of the non-parametric tests we have. We have other non-parametric tests like the sign test, the Wisconsin test, and the rest of them. But today we are looking at the chi-square test. So the other 2 types of measurement scales, the interval and the ratio, data gotten using ratio and interval scale are measured or are tested using the parametric test, and those data are quantitative data. So data that are gotten from the nominal and the ordinal scale are qualitative data. I hope this is understood. So the chi-square test uses contingency table to analyze data. A contingency table is also known as a cross tabulation. It is a cross tabulation. This is an example of a cross tabulation, putting the data in rows and in columns. So they are known as a cross tabulation. So a contingency table is also known as a cross tabulation. And again, it is important to know that the cross tabulation is an arrangement in which data are classified according to 2 categorical variables. The categories for one variable appear in the rows, I said that before, and the categories for the other variable appears in the columns. Now there are certain assumptions that must be met before we can use the chi-square test for independence. So assumptions that must be satisfied. So permit me to claim this definition. Assumptions for using the chi-square test for independence. There are certain assumptions that must be met. Certain assumptions that must be satisfied. Now we call it assumptions for using chi-square test. We'll highlight them one after the other. So I believe this part is clearly understood. So permit me to also clean all these as we progress in this class. Please subscribe to my YouTube channel, Dr. Chris Esekaibe, and share my videos in your social media platform, your Facebook, WhatsApp status, and the rest of them. The essence of this channel is to share knowledge across the globe, to teach topics in mathematics and statistics, both at tertiary level, at undergraduate level, and postgraduate level. And if you do that, God will bless you. So now we are going back to the assumptions for using the chi-square test. Number one assumption is that the two variables should be measured at an ordinal or nominal level. Nominal or one, the two variables must be measured at nominal stroke ordinal level or scale. That means they must be categorical. That is what it means. So the data must be categorical, or let me put it in full, categorical data. So that is the number one. So we use the chi-square test for independence. Some authors call it chi-square goodness of fit test, to analyze ordinal or nominal data that are measured using the nominal or ordinal scales. The number two assumption that must be made is that each of the groups must be randomly selected and independent. So you know it involves two variables. So each group must be randomly and independently selected. There will be no manipulation. It will come the way it is. So the various groups must be randomly and independently selected. Then again, assumption number three, before using or applying the chi-square test, each frequency in each cell must be reasonably large. Each frequency in each cell must be reasonably large. That is, when we say reasonably large, it must be greater than or equal to 5. So there is no cell that must have a frequency that is less than 5. So it must be reasonably large. When we talk about being reasonably large, it means that each cell must have frequency that is greater than or equal to 5. It must not be less than 5. If it is less than 5, then if that assumption is not met or satisfied, then the test will be invalid. Now, the chi-square test statistic is written thus: chi-square test statistic. Now, the chi-square test is written as this: chi-square is equal to summation I is equal to 1 to arrow. Arrow means the number of rows. J is equals to 1 to C. C means the number of columns to C. Then you now have bracket open O ij minus eij. This is small letter eij. You square it all over eij. This is the test statistic for the chi-square test. And of course, we have r minus 1 into c minus 1 degrees of freedom. So the O here, OIJ, means observed frequency in ith row, jth column. That's what it means. Then the EIJ means the expected frequency in the ith row and the jth column. That is what it means. So now it is expedient, or it is good, we understand how the expected frequencies are calculated. The expected frequencies, if we want to calculate the expected frequency, permit me to write it here. You have the EIJ will be equal to rho I total times column J total all over the grand total. All over the grand total. So that is how the expected frequency is calculated. Please note, the calculated chi-square is gotten from the test statistic using this formula. This is the this formula that will give us the calculated chi-square. Remember, in our test of hypothesis, using the chi-square test for independence involves testing of hypothesis. And in our last topic, in our last class, when we treated test of hypothesis, the first thing we said is to set the hypothesis. After setting the hypothesis, then we will now get the level of significance alpha, then we get the appropriate test statistic, then we get the table values. Then after getting the table values, we now make decision and conclude. Those are the steps for using the those are the steps or procedure for testing hypothesis. So permit me to clean this. I hope the assumptions are well taken note of. Please wait patiently as we take one or two examples before we round up this class. It is good we solve practical examples and see how this thing is applied. Please be patient. I will plead with you to be patient to the end of the class so that you can have a better understanding. So for the chi-square test, the chi-square test is not different from any other test of hypothesis. It is the same decision rule. Like we said, you know, if the critical chi-square is greater than the if the calculated chi-square is greater than table chi-square, you know, the decision rule will be this. Decision rule. We said this in our test of hypothesis. If calculated chi-square, that means we can put it as this, is greater than table chi-square, reject HO, otherwise accept HO. That's the decision rule. Using the table value, that means if chi-square calculated is greater than chi-square table value or critical value, reject HO. And we're told that when HO is rejected, of course, the null hypothesis is HO, it is rejected, then the alternative hypothesis H1 will be accepted. So you'll be very careful in accepting or rejecting HO so that you don't commit what we call type 1 or type 2 errors. We have two types of errors in our hypothesis testing, the type 1 error and the type 2 error. So you'll be very careful so that you don't make such an error. Now, there is a way we interpret chi-square test when we use SPSS. Now, I've been doing a lot of teaching. Most of this, it is better you understand these teachings manually, so that by the time you now start using any statistical packages, there are many statistical packages that can be used. We can use the SPSS, we can use the Minitab, we can use the SSP, we can use the eView, we can use microfit. There are many statistical packages that we can use. Some are old, but are still functioning, still getting results. Some are new for data analysis, for data modeling, like the Power BI and the rest of them. There are also recent statistical software that are in use. But if you are using a statistical software, the statistical software will produce or calculate what we call the p-value. This one is when you are using the table value. The second one, if you are using p-value, now to make a decision, if you are using, maybe for instance, when using SPSS, SPSS is a statistical package for social sciences. You can use SPSS to calculate chi-square, to run a chi-square test for independence. You can use the SPSS, you can also use the microfit, you can use the SSP to run it. Now the p-value will be given. And how do you now make a decision when you have the p-value and the alpha? Now, when using the SPSS, what you just need, if the p-value is greater than the alpha, I told you what alpha is. Our alpha, you accept HO and reject H1. Remember the two types of hypothesis, HO and H1. So now, the alpha here, let me tell you, alpha means the level of significance. Is the level of significance. And it is also the probability of committing a type 1 error. So you should know this. So again, if p-value is less than alpha, that means HO will be rejected. But if p-value, the probability value, you will see the probability value, the statistical package for social sciences, the SPSS or any other statistical package will help you to calculate it. The printout of results will show the p-value. One problem is that a lot of people that don't understand all these things cannot interpret results from any statistical package used. So you need to understand all these techniques manually, so that when you see any printout of results from any statistical package used, whether SPSS or SSP or SSP is a Smith statistical package, or the eView or the microfit and the rest of them, you can interpret it easily because you are already used to the manual computation. And again, if you are not also used to the manual computation, you cannot even impute this data. You can't use these packages effectively well. You need to understand them, how they work manually. You need to understand how these tests work manually before you can now use any package to use them to solve, or use any package to run them. So that is that. Now we want to take a practical example that involves the analysis of chi-square. I hope the decision rules are taken, and the steps for hypothesis testing are also part of what we are going to be using. Now, there is a particular example from the data given below. Find out whether there is a relationship between gender and academic performance at 5% level of significance. From the data below, find out if there is any relationship, between gender and academic performance. In academic performance in a particular university at 5% LOX. Please, when you see LOX means level of significance. So that is the level of significance for the test you have to carry out. So permit me to write out the table. Now we have academic performance. Now we have of course, here we have the gender. So we have the male and we have the female. Okay, let me write the gender here. Gender. We have the male, we have the female. So we have it this way. Then the first academic performance in the university is the first class. Then the second one is second class upper. Then the next one is second class lower. And the next one is third class. The next one is third, or let me just write it this way, third class. So now, permit me to separate them in cells. So we have it this way. Then we have our totals here. So it's as simple as this. So also we have our totals here. If it comes down like this, we have our totals. So our totals here. You can see these cells. It's an example of a contingency table. Now, under the males, we have 20 first class. We have 20. For the second class upper is 35. Then the other one is 40 and 10. The total is 110. Then for the female, we have 25, we have 30, we have 40, and we have 15. And the total is 110. Then of course for the total, here will be 45, here will be 65, here will be 80, here will be 25, and here will be 220. That's the grand total. So the grand total will be 220. So you can see how this has brought. So the step 1, now we are taking it in steps. Step 1 will be the calculation of the calculation. Step 1 will be the calculation of or the statement of the null hypothesis. I'm able to take it up like this. So step 1, so we have the HO. HO will tell you that there is no relationship between gender and academic performance. There is no relationship between gender and academic performance. Then our H1, of course, we told you in our test of hypothesis that the H1 will always contradict or negate or oppose the null hypothesis. So this one will now say there is relationship between gender and academic performance. Permit me to write it in short. An academic performance. So those are the two hypotheses that we have. Now that we have gotten that, our step 2 will be the computation of the expected values. Remember, the chi-square test statistic involves the observed value. These are the observed value or the observed frequency. Then the expected frequency will be calculated. Now step 2, compute the expected frequencies. Now I will start. These are the cells. We have 8 cells. The totals are not part of the cells. This is E11, E12, E21, E22. These are the cells. So now this is O11, O12, O21, O22, O31, O32, O41, O42. Now the expected values are what we want to calculate. Now the first one is for E11. For E11, I want to calculate the expected for E11. Now the total from the row side is 45. So it will be 45 times the total from the column side is 110. All over the grand total is 220. So you say 45 by 110, divide the answer by 220, you are going to get 22.5. So this one will give you 22.5. Now what we normally do, please permit me to write this. This is 20. I will put the expected value in bracket, 22.5. Now I want to get for E12. The total again for here is, for the row is 45. Then the total for the column, of course, is the same thing as 110. All over the grand total 220. And when you come again, you will get 22.5. So permit me, this is 25. So this will be 22.5. So I want to come again for, now permit me to use this place, E21. This is E21, which is 35. The total here is 65. The total here is 110. So this will be 65 times 110 all over. The grand total is 220. When you carry out that calculation, you are going to have you are going to have 32.5. So you come here, you have 32.5. So you come here, let me write this 35 here, 35, then the expected value will be 32.5, we put it in bracket. Then the next one is for E21. So our E21 will be equal to, look at it now, 21, the total is 65, it's also, so this will be 65 times also 110 all over 220, and that will also be 32.5. So you come here, this 30, you write it here, and you put 32.5, you cover it. Then for the next one, for the E31, you come here, your E31, that means the third row and the first column. For this one, the total is 80, then the row total is 80, the column total is 110, so it will be 80 times 110 all over 220, which is the grand total. What are you going to get? You are going to get 42.5. So you're going to have 42.5. So you come here for this one, you come here again, this is 40, you put 42.5. You have 42.5. Okay, here is 45. So you have 42.5. Okay, here is 85. This is 45 and 40. Here is 85. Okay, so that is correct. Now you have that. Then for E32 is this one. Let me write the 40 by the side. So this will be the total for the row is 85 times, and the column is 110 all over. This is 85, please. All times all over 85 times 110 all over the grand total 220, and that is 42.5. So you come here, the expected value is 42.5. So take note, let's look at the data again. We have 20, 35, 45, 10, then the total for this column is 110. We have 25, 30, 40, and 15. The total is 110. We are on track. Now, permit me to clean this part so that we can get for the last rows. For the last row. So now we are looking at E. We are looking at E41. E41. Look at this one now. It will be 25 times 110. 25 times 110 all over the grand total is 220, and that will be equal to, when you get that, 12.5. So you come here, you can write this 10 at this corner, 10, then you put your 12.5, then of course this 15 right at the corner, so that will come and put the value there. Then we get for E42. So of course for the row total again is 25, then the column total where the 15 falls is 110 all over the grand total to 20, then of course that will be equal to also 12.5. So this is 12.5, then you cover the bracket. Now the beautiful part thing there is that if you add these expected values, these are the observed values that came with the question, then these are the expected values. You have seen how we calculated the expected values. If you add this 22.5 plus 32.5 plus 42.5 plus 12.5, you will also arrive at 110. If you add 22.5 plus 2.5 plus 42, you will arrive at this. If you add also the column and the rows, you get the row total 45, 65, 85, and 25. Then the grand total will now be 220. So the sum of the expected frequencies must be equal to the sum of the observed frequencies. I come again. the sum of the expected frequencies must be equal to the sum of the observed frequency. That is how it works. So now, the step 3, now that we have stated our null hypothesis and an alternate hypothesis, and we have gotten, we have calculated the expected frequencies. Now, the step 3 is to calculate or compute the test statistic. So permit me to clean all these parts so that we can compute our test statistic. That's the step 3. The step 3 is to compute the test statistic. So step 3 now, step 3, compute the test statistic. So that means our chi-square is given by this formula: summation, I is equals to 1 to C to R. R is the number of rows to R. Then J is equals to 1 to C, the number of columns. O I J minus E I J. O stands for the observed frequencies, while A stands for the expected frequencies all over the EIJ. So our chi-square goes to us. You observe patiently as we go ahead. Now we have 8 cells here. Under male, the gender, you can see now there are the two variables that we are testing. The variables are gender and academic performance. We are trying to look at study the association or relationship between gender and academic performance in a particular university. And these are the records from the university. 220 students, results from 220 students were used for this test. Now look at the observed values, the original value. We now calculated the expected values by the side. Now we want to apply this chi-square test statistic to get the chi-square calculated value. So now the first one here is 20 observed. So this will be 20 minus 22.5 all squared, observed minus expected. You put the square here, then all over the expected. What is the expected? 22.5. So the summation runs from the rows to the columns down to the last value. We have 8 cells here, so we are going to do it in 8 places. Then plus the next one, I take it row by row. The first, the observed value is 25 minus the expected is 22.5 all squared all over what is the expected 22.5. Then you come again, you put your plus because it's summation is running through. You come to the second one here. This one is 35 minus the expected is 32.5 all squared all over 32.5. Then plus the next one here is 30 minus 32.5 all squared all over 32.5. So you can see we are making progress. We are done with these two. Then the next one is this one plus 45 is the observed minus the expected minus 42.5 all squared all over the expected. The expected is 42.5. Then plus, then the next one is this 40, which is the observed value, minus 42.5 all squared all over the expected value 42.5. And you come again plus the last one here is 10 minus 12.5 all squared all over 42.5 all over 12.5. That's for this one. Then the last cell is adding the observed value to be 15 minus 12.5 all squared all over the expected is the one in bracket all over 12.5. Then you put your equal to sign. So these are the 8 cells. You can see 1, 2, 3, 4, 5, 6, 7, 8. These are the totals. They are not counted. If you count 1, 2, 3, 4, 5, 6, 7, 8. So it is complete. Every cell is captured in our analysis. So if you put these values together, it is good we calculate each of them and see what the value will be like. So now permit me to come here. I want to put it this way. Chi-square will now be equal to, if you take this first one, 20 minus 22.5, you will square it before you divide it by 22.5. You are going to get 0.2778. 0.2778 plus, of course, let me roll this down here. Then you take the second one, 25 minus 22.5. Then you now square the answer. That will be again plus 0.2778. Then plus the third one, 20 minus okay, that is 35 minus 32.5. 35 minus 32.5, you square the answer and you now divide it by 32.5. You are going to get 0.1923 plus 0.1923. Then you come here again plus, then you take the fourth one, 30 minus that, and you square it, divided by that, you will still get the same, plus 0.1923 plus, then you come to this one, 45 minus 42.5, you square the answer, you get 0.1471, 0.1471 plus, again you come here, 40 minus 42.5, you square it, divided by 42.5, you will still get the same number, the same value, 0.1471. Then again you come here plus, then this one, 10 minus 12.5, of course you have minus 2.5, you square it, then you divide it by 12.5, divided by 12.5, you are going to get 0.5. So you have 0.5 plus, then the last one, 15 minus 12.5, that will be 2.5, you square 2.5, then you divide it by 12.5, you're still going to have 0.5. So this answer will now give us, when you add everything up, you are going to have 2.2344. 2.2344. So when we come here now, our chi-square calculated is equal to 2.2344. That is what we have gotten as our calculated value for the chi-square. So it doesn't end there. We are going to take another step further. That step is step 4. Permit me to clean this question so that we'll take a look at the step 4 before we now make our decision and conclude concerning this particular test. Remember from what we said, you cannot accept the two hypotheses. It's either you accept one and reject the other. We have the decision rule for that. If you are using the statistical package, the PSS, you use the p-value and the alpha, that is the level of significance. But if you are doing it manually, you can use the table value. Now step 4 is to get chi-square tabulated with r minus 1 into c minus 1 degrees of freedom. So that will be equal to our degrees of freedom. So our df will be equal to, our number of rows is 4. 1, 2, 3, 4. So we're going to have 4 minus 1. Then our number of columns is 2, male and female. 2 minus 1. So it will be 3. 4 minus 1 is 3 times 2 minus 1 is 1. So our degree of freedom is 3. So now this implies that our chi-square tabulated at 0.05. Remember, our alpha is equal to 5% and is equal to 0.05. So now we are going to check the table value at 5%. Now, all you just need to do, if you don't have the chi-square table, download it, just say the chi-square statistical table. It's a simple table, the chi-square statistical table. You can search it on the internet, download it. Then you will now see on the column, it has columns, and the rows are the degrees of freedom. It has columns and rows. The columns have the alpha. You will see 0.05, you will see 0.2, 0.025, you will see 0.1, you will see 0.01. For instance, 5% simply means 0.05. So you will now check 0.05, you will now check it under 3. You will now check it under 3. So that's why you check 0.05 under 3. That particular value, you will see the value there, 7.815. You have 7.815. So this will now be the table value. So you will just download the chi-square statistical table. It's a very simple table. Just download it. Check the columns. The columns are having the alphas, the level of significance. If 0.05, of course, when you divide it, you divide this one by 100, you get the same thing as in a decimal to the 0.05. You divide 5% by 100, you get 0.05, change it in decimal. So it is the decimals that you see here. If it is 1%, you will see it will be 0.01, and so on and so forth. So you will check from the column, check 0.05, then go to the rows. The rows there are the degrees of freedom, DF, degrees of freedom. And we have calculated it. It's calculated as row minus 1 multiplied by column minus 1. Our rows here are 4. 1, 2, 3, 4, because first class, second class upper, second class lower, and third class. So the rows are 4. Then our columns are 2, the gender. So you know the chi-square test is the test that involves categorical data that involve categorical data, and the data must be in 2 variables. So one will be in the column, one category will be in the column, the other category will be in the rows. So the one in the column here are the gender, male and female. Then the one in the rows are the academic performance from the university. So now we have been able to get our calculated chi-square to be 2.2344 and our table value to be 7.815. Permit me to claim step 3 as we go to step 5. Step 5 now involves your decision making. You decide and you make your conclusion. You decide and you make your conclusion. That will be our step 5. Step 5 means decide and conclude. So step 5. Decision. So conclusion. That's what we are doing here for step 5. Now we come, the decision rule says if chi-square calculated is greater than chi-square tabulated table value, reject HO. That is what he said. But now, our decision will now be, since, what is our chi-square calculated? Since chi-square calculated, the value is 2.2344. Since, okay, let me not put the values. Since chi-square calculated is less than chi-square tabulated, that is 2.2344 is less than 7.815. So what do we do in this case? If it is less than That means we are going to accept HO. So since this is that, we accept HO and conclude that there is no relationship between gender and academic performance in that university at alpha is equal to 5%. So that is how we conclude on this particular problem. Below, this is one example that we have solved. So we are going to take a look at another example before we close for the day. Please subscribe to my YouTube channel, Dr. Chris Esekaibe. Click on the bell button, the notification button, so that anytime I upload a video, you will have a notification. Like my videos, share them on your social media platform, on your Facebook, your WhatsApp platforms, and other social media platforms. Be part of those sharing knowledge across the globe, because the essence of this YouTube channel is to share knowledge across the globe. So below, this is the end of the concluding part of this particular example. Permit me to clean the board so that I take another example again before we round up for today. By the time we take another example, I believe the understanding will be better. Please wait patiently to the end of the class before shutting down, so that you can have a better understanding of what chi-square test for independence is all about. If by the time we take the second example, you will see that we can call this one example 2. This one has to do with so there is no relationship between gender and academic performance. That is what the first conclusion of that particular example 1. So now example 2, the table below shows a sample of students, non-student volunteers. Shows a sample of students, non-student volunteers. And the number of hours volunteered in taking care of old disabled citizens. Taking care of old disabled citizens. So you have to, the question is the number of hours volunteered independent of the type of volunteer? The question is the number of hours volunteered independent of the type of volunteer? Test at alpha is equal to 5%. So you are testing at 5% level of significance. You are testing at 5% level of significance. So the table is given below. The table is given below: type of volunteers, type of volunteers, okay. Then we have, of course, on top here we have the hours, of course. Then we have 1 to 5 hours, and we have 6 to 10 hours. Then, of course, we are going to have our totals. So for the volunteers, the type of volunteers, we have the students and the non-students. So these are the two we have. So we also have our totals here. Okay, let's not take much space. So we have this. Now for 1 to 5 hours, we have here under here 40, here we have 60. Okay, let me write it by the side. We have 40, we have 60. Then the other one, we have 30, we have 50. Of course, the total here is 100. And the total here is 80. Then the next totals, of course, here will be 70. Here will be 110. And of course, our grand total is 180. So our grand total will be 180. 70 plus 110 is 180. 100 plus 80 is 180. So permit me to take a step further. I think the first thing here, now the step 1 is to get the null and alternative hypothesis. You have to state the hypothesis. So step 1, HO will say that the number of hours volunteered is independent of the type of volunteers. So the hour of volunteer is independent of the type of volunteer. Then our H1, the alternative hypothesis, will be the hour of volunteer is dependent of the type of volunteer. So you can see that the alternative hypothesis opposes or contradicts the null hypothesis HO. HO says the hour of volunteer is independent of the type of volunteer. We have two types of volunteers: students and non-students. Then the number of hours weekly. So these hours are weekly. So these hours are weekly. So the table shows a sample of students, of non-students, volunteers, and the number of hours volunteered weekly. Please, there's weekly here. Weekly and taking care. So the volunteer is weekly. So we have 6 to 10 hours weekly. The data there, you can see the account data. Then 1 to 5 hours. For 1 to 5 hours for students, volunteer, they input 40 hours. For non-student volunteers, 60. For 6 to 10 hours for student volunteers, they input 30 hours in taking care of the old disabled citizens. Then for the non-students, they input 50 hours in taking care of the old disabled citizens. Now, it is time to calculate. The step 2 now is to calculate the expected frequencies. So step 2, calculate the expected frequencies. Now we have those 4 cells here. So this is E11, E12, E21, E22, as simple as that. So for E11, this is for 40, the total here is 70, remember? Then the total here is 100. So this will be 70 times 100 all over. The grand total is 180. So 70 by 100 all over 180 is 38.89. So you put it here. 38.89, close the bracket. So it will be 38.89. Then for the E12, the E12 is this one, it will be 30. The sum here is 30, that is the sum of the row where it belongs and the sum of the column. So this will be 70 times the total here is 80 all over 180. Then when you carry out that estimation, you have 31.11. 31.11. I like taking it up to 2 decimal places. 31.11. Then you close the bracket. Then you separate it. Then for E21, this is E21. So the total for that row is 110. Then the total for the column is 100 all over 180. So 110 times 1 over 1 is 61.11. So you have 61.11. So you put it here 61.11. Then you close the bracket. Then finally for E22, the total for this is 110 for the row. Then the column is 80 all over 180. When you carry out that multiplication and divide by 180, you have 48.89. So you have 48.89. You come here, you open the bracket, 48.89. So this is how it is done. So the observed values are the ones, or observed, you can call them observed value or observed frequencies, are the ones outside the bracket. Then the ones inside the bracket are the expected frequencies. So we have done well by doing that. So permit me to clean off the hypothesis so that we go to step 3. Step 3 now, we are to compute the test statistic. We are to compute the test statistic. So that is step 3. Step 3. So step 3, compute chi-square test statistic. So coming out of our chi-square, of course the formula is summation I is equal to 1 to the number of rows, j is equal to 1 to the number of columns, oij minus eij all squared all over, you see the square does not cover the denominator, all over the eij. So our chi-square now will now be equal to, we start from the first from the first cell. It will be observed is 40, this will be 40 minus 38.89 all squared all over. Then the expected is 38.89. Then you put your plus. Then the next one is 30. This will be 30 minus 31.11 all squared all over. The expected is 31.11. then you come, you put your plus, then the next one here is 60 minus the expected, the observed is 60, the expected is 61.11 all squared all over the observed, all over the expected, which is 61.11, then plus finally the last cell, it will now be 50 minus 48.89 all squared all over 48.89. So you can see we have gotten that. Then you put your equal to sign here. Permit me to clean step 2 so that we can have space to continue with our calculation. You have seen how the expected frequencies were calculated. It's as simple as ABCD. Please wait patiently, watch this video to the end so that you will understand better how the chi-square test for independence works. So continuing with this, our chi-square will be equal to, when you get the first value there, you are doing, if you say 40 minus 38.89, you square it and divide it by 38.89, you get 0.03168. 0.03168 plus, then you go to the second one, 30 minus 31.11, you square it and divide it by 31.11, you get 0.0396. 0.0396, then plus, then you come to this one now, 60 minus 61.11, then you square it, divide it by 61.11, you get 0.0216. 0.0216. We have 0.02, okay, 0.02016. Then plus the last cell there, which is 50 minus 48.89, then you square that difference divided by the expected value 48.89, then you are going to get 0.0252 plus 0.0252. So you now come here, adding all this together, our chi-square, you can call it chi-square calculated. Our chi-square calculated will now be 0.1166. 0.1166. That's our chi-square calculated. So now, permit me to get our chi-square tabulated. Here now, our degrees of freedom, df, will be equal to r minus 1 into c minus 1. So, okay, permit me to put it down here. Our df, degree of freedom, is equal to r minus 1, that is the number of rows minus 1, multiplied by the number of columns minus 1. So the rows here are 2, the columns are 2. 2 minus 1 into 2 minus 1. 2 minus 1 into 2 minus 1. So 2 minus 1 is 1, 2 minus 1 is 1, 1 minus 1 is 1. So our degrees of freedom is 1. So now, and we are testing our alpha is equal to 5% and is equal to 0.05. So now the chi-square table value will now be chi-square at 0.05, 1, the degree of freedom. So you will go back again to that chi-square table, check under from the columns, locate 0.05. There are various alphas there. You will see 0.01, 0.1, 0.025. But the one that concerns you that you are given to work with is 0.05. Locate 0.05, then check the degrees of freedom. The degrees of freedom are the rows. You now check 1 under 0.05. And the value that you will see here is 3.841. So I'm going to have 3.841. That is what you have. So that is our step 4. We have gotten the table value. This is step 4. we have gotten the table value. So our calculated chi-square is 0.1166, while our table value is 3.841. Permit me to clean the question so that we can make our conclusions through decision, or decisions to conclusion. Is very, very important. It's very, very important that we conclude wisely. So please wait patiently to the end. It's chi-square test. Chi-square test of independence. So please wait patiently. Now step 5. Step 5. We are talking about decision to conclusion. So now the decision says if chi-square calculated is greater than chi-square table, reject HO. Now, since our chi-square cal is less than our chi-square tab, that is, our chi-square calculated is 0.1166, is less than, we can put is less than 3.841, we accept HO. Then when you accept HO, the way you conclude, you will now go back to the null and alternative hypothesis that we formed. Then we now conclude that from here, we now say that the number of hours volunteered is independent of the type of volunteer. So we come here and say the number of hours volunteered is independent of the type of volunteer. So this is our conclusion for this particular test. This is our conclusion. The conclusion is here. So this is our conclusion. So that is the conclusion. So we have accepted HO, and HO says the number of hours volunteered, is independent of the type of volunteer. I believe you have learned a lot from the chi-square test for independence. It's a goodness of fit test. It is used to test the association between two categorical variables, and the categorical variables are measured using nominal and the ordinal scales. And again, you have been able to look at test of hypotheses in practical. This has gone a very long way. I believe if you come across any problem on a categorical data, or any problem that has two variables, one on the row, the other one on the column, and they are categorical, then you should know that the best test to use is the chi-square test. And you see, among the assumptions, each cell has greater than 5. So one of the assumptions is that each cell or each frequency must be greater than or equal to 5. So no cell should have below 5. And you see the two problems we solved met the assumption, satisfied that third assumption. Please watch through the video from the beginning to the end so that you can understand the chi-square test for independence clearly. It's a very good test to use for categorical data, data that are in two categories, one on the row, the other one on the column. You have seen how we are able to solve the problems from step 1 to step 5. So watch the video to the end. Thank you for waiting patiently to the end of this video. Once again, my name is Dr. Chris Isekaibe. Subscribe to my YouTube channel so that this channel can grow. Be part of those that are sharing knowledge. The essence of this channel is to share knowledge across the globe, to share knowledge in mathematics and statistics, because I am an expert in numerical analysis, data analysis and modeling, and scientific computing and statistical analysis. You can consult me with your research work. If you are an artificial intelligence firm, why not? We can work together. My contacts were displayed at the beginning of the video. You get them. My email address is also there. The first number and my contact is also for WhatsApp. You can send me WhatsApp message, share the videos across the globe and your social media platform. If you have any thing you want me to do for you, or you have any problem in any topic, you can as well put it in the comment section. Then it will be treated accordingly. God bless you for your patience. Have a great day. Bye.